Suppose if you consider any two molecules or any one of the molecules, if it is having the resonance structure and if you are not able to predict the structure, that can be easily predicted by using what? VSEPR theory. The central metal atom has 5 electrons in its outermost shell, and that 5 electrons are get paired up with the single chlorine atoms and forming a PCl5 structure. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Chemical Bonding and Molecular Structure. Under that, we have discussed about the remaining hybridization. Under that, we have discussed about sp3 hybridization and sp3d hybridization, and also we have learnt about sp3d2 hybridization. Today, we will move on to the next topic of this unit about the postulates of VSEPR theory, that is valence shell electron pair theory, and we are going to understand the geometry of the molecules in which central metal atom has no lone pair of electron, and again we are going to understand the geometry of the molecules with a central atom with one or more lone pair of electron. At the last, we are going to discuss about the production of the shapes of the molecule along with by using VSEPR theory. So let's see what is VSEPR theory and what are the postulates first. Okay. The VSEPR theory states that the shape of the molecule depends upon the number of valence electron pairs around the central atom. So what does the first postulate says? The first postulate says that the shape of the molecules that can be predicted based upon the number of valence electron which is there in the outermost shell of an atom. Especially to the central atom, we consider that valence electron. Okay, and the pairs of electron in the valence shell, they repel one another since their electron clouds are negatively charged. So if it is consists of valence electron, this pairs of valence electrons, they repel with one another because of the oppositively charges. Okay, and these pairs of electrons tends to occupy the position in the space that minimizes the repulsion and maximizes the distances between them. So when a pair of electrons are there, when it is oriented in a space, that minimizes the repulsion and maximizes the distances between them. And fourth postulate states that where two or more resonance structures can be present for a molecule, thus VSEPR theory is help us to applicable to the such structures. Suppose if you consider any two molecules or any one of the molecules, if it is having the resonance structure and if you are not able to predict the structure, that can be easily predicted by using what? VSEPR theory. And the repulsion of electron pair decreases in the order, that is lone pair and bond pair, which is usually greater than bond pair and bond pair. So this is how we have a decrease in the repulsion or interactions between electron pair. So what does it tell us? It tells about the whether the central atom which consists of how many electrons in its valence shell, that electron which describe the shape of the central metal atom, and the electron which is present in the outermost shell, they repel one another because of the opposite charges. Okay, and usually if the resonance structures which has been there for a molecule, if you can't decide the shape, that can be easily decided by using VSEPR theory, and it tells us that the repulsions will be usually in the order of lone pair, lone pair, lone pair, bond pair and bond pair, bond pair. Okay. Now, let's see how we can easily predict the shape of the molecule by using VSEPR theory. For the prediction of geometrical shape of the molecule with the help of VSEPR theory is convenient to divide the molecules into two categories? So first is the molecule in which the central atom has how many lone pair of electron? No lone pair of electron. In second case, we will consider the molecule that is a central molecule having one or more lone pair of electron. This is how we can easily divide the molecules into two categories. Thereby, by using VSEPR theory, we can easily predict their shape. So, how we can divide the molecules? We can divide the molecules into two types, where the molecules have no lone pair of electron. Where the molecules having a lone pair of electron, like this we can divide the molecules into two categories. Based on that, we can predict the shape of the given molecule based upon VSEPR theory. Hence, it is known as valence shell electron pair theory. This theory is mainly based on what? Number of electrons which is present in its outermost shell or in the valence shell. Hence, it is named as valence shell electron pair theory. Now, let us take the first condition, that is the geometry of the molecules in which central atom has no lone pairs of electrons. Okay. Here you can see that the number of electrons in the first case, you can see that, imagine this is a central metal atom having how many lone pairs of electron? 2 lone pairs of electron. If 2 lone pairs of electron which is there for the central atom, their geometry will be linear. Example is beryllium chloride and mercury chloride. So what does it tell us? We know that beryllium has how many electrons? 2 electrons. Is it right? Yes. And it has an electronic configuration of 1s2, which indicates that there are 2 electrons which is unpaired. Is it right? Yes. So these 2 electrons, get paired up by what? Chlorine atom and forms beryllium chloride. So this indicates that the central atom has no lone pair of electron, hence it has the geometry of linear shape. Okay, and the example is beryllium chloride and mercury chloride. Similarly, I'll go with the next one. The number of electron pairs are 3 and it has trigonal planar structure, and you can see that the geometry of the molecule will be trigonal planar. Example is BF3. What does it indicate? Boron is having how many electrons? 3 electrons. Is it right? Yes. So boron has 3 electrons. These 3 electrons will be present in its outermost shell and get bonded with the fluorine atom and forming what? BF3. Hence, the structure will be written as BF3, where 3 electrons which is present in its outermost shell. Okay, which has been paired with the fluorine atom and forming BF3, and it has a structure of trigonal planar or trigonal planar, you can say. Similarly, I'll go with the central metal atom having 4 electrons in its outermost shell. So, example is CH4 and NH4. I'll go with the CH4. We know that carbon is having the electronic configuration of 1s2, 2s2 and 2p2. So, in the outermost shell, it consists of how many electrons? 6 electrons. Is it right? Yes. That is why all the 4 electrons of the carbon get paired up with 1 hydrogen atom, because each hydrogen atom which donates how many electrons? 1 electrons to the carbon and forming what? Tetrahedral geometry. And forming what? Tetrahedral geometry, and hence it is known as CH4 or NH4 plus ion. Okay, this is how, if the central metal atom has a 4 electron in its valence shell, it exhibits a tetrahedral shape. If the central metal atom has a 3 electron in its outermost shell, it shows the trigonal planar structure or trigonal planar structure. If the central metal atom has 2 electron in its outermost shell, that is in the valence shell, it expresses its linear shape. Okay, so based upon the electron which is present in its outermost shell, we are predicting the shape of the molecule. Okay, next is if the number of electron in the central atom is 5, that is, it indicates that in its outermost shell it consists of how many electron? 5 electron. So now let us take the example of PCl5. We know that the PCl5, in the PCl5 we know that phosphorus is a central metal atom which is having 15 electron is the electronic configuration of phosphorus, and if you write the structure of the electronic configuration, it goes like this. That is 1s2, 2s2, 2p6 and 3s2, 3p3. So this indicates that in the last shell it consists of how many electrons are unpaired? 5 electrons will be unpaired, or 5 electrons will be there in its outermost shell. Hence the valence of the phosphorus will be 5. Is it right? Hence all these 5 unpaired electrons are get paired up with the each single chlorine atoms and form a PCl5 structure, and it has a trigonal bipyramidal shape. Already while studying the hybridization concept, we have understood that PCl5 is undergoing sp3d hybridization and it has a geometry of trigonal bipyramidal shape. The same thing I have considered here because the central metal atom has a 5 electron in its outermost shell, and that 5 electrons are get paired up with the single chlorine atoms and forming a PCl5 structure. Next I'll go with the central metal atom having the 6 electron in its outermost shell. So example is SF6. You can see that in SF6, that is sulfur is a central metal atom and it has electronic configuration of 1s2, 2s2, 2p6, 3s2 and 3p4. You can see that this is the last shell which consists of how many electrons? 6 electrons. Each 6 electrons are unpaired. They get paired up by using what? Fluorine atom, 6 fluorine atom, and hence the shape will be SF6. And it shows what? Octahedral structure. It is a regular octahedral structure. Is it right? Yes. This is also we have observed in case of hybridization, where this kind of hybridization involving the d orbital, and this is a sp3d2 hybridization. Is it right, children? Yes. So these are the two things which we have already learned in the hybridization concept. Now let us take how to predict the geometry of the molecules if central metal atom has 1 or 2 lone pairs of electron. In the last case, we have discussed that if the central metal atom is there having no lone pair of electron, how to predict their shape. Now we are going to understand the geometry of the molecule where the central metal atom has 1 or more lone pair of electron. Then how to predict their structure? Let us see now. First I'll go with the molecule type, that is AB to E. Okay. Here the number of bonding pairs of electron is 2 and number of lone pairs of electron is 1. You can see that this is a central metal atom having 2 bonding pairs of electron and this is a 1 lone pairs of electron. The best example is ozone and SO2. Ozone and SO2. So we know that in the ozone, it has a structure of O like this. Is it right? And we know that always the central atom which carries what? 1 lone pairs of electron. So, and it has a shape of bed shape. Okay. Now I'll go with the molecules type of AB3E. In that, central metal atom having what? 1 lone pair of electron with 3 bonding pairs. 3 bonding pairs of electron. You can see that in case of ammonia. So if you write the ammonia structure, this is NH3. The central metal atom having how many pairs of electron? Only one pairs of lone pairs of electron, and it has been bonded with 3 hydrogen atom. Ma'am, why is like that? You can understand that by writing the electronic configuration of nitrogen. We know that in case of nitrogen, there are 7 electrons will be there, and it can be written as 1s2, 2s2 and 2p3. Is it right? Yes. So this is a last shell where it consists of 5 unpaired electrons. In that, you know, the 3 electron which is there in the p orbital get overlap with the 3 different hydrogen atoms and forming 3 bonds. Whereas the electron which is present in s orbital, which is a lone pair of electron which is found on the nitrogen atom, and remain it is unhybridized, or it do not forms any bond with any molecule. Hence it is known as lone pair, and these are the 3 bond pairs. Okay. So hope you all understood with this AB3E type. Next, I'll go with the AB2E2 type. In this, central metal atom has how many lone pair of electron? 2 lone pairs of electron with the 2 bond pairs of electron. The example is water molecule. You can see that in case of water molecule, we always write the structure like this, and it is a bent structure. We know that oxygen carries how many lone pairs of electron? 2 lone pairs of electron. Ma'am, why it consists of 2 lone pairs of electron? Again, you can write the electron configuration of the oxygen, and you can understand that in that how many electrons will be act like lone pairs. Okay. So, in case of water molecule, it has a 2 lone pairs of electron, and there are 2 bond pairs of electron. Hence, it exhibits the shape of bent. Okay. Next, I'll go with the AB4E type. In this, central metal atom has a 1 lone pair of electron and 4 bond pairs of electron. So, the example is SF6. Okay. Already we have discussed with this structure, that is a trigonal bipyramidal shape, is a shape of SF6, where central metal atom is a sulfur. We know that in the sulfur, it has how many electrons? 16 electrons. And the electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p4. So it is 10 and 16. Is it right? Yes. So in that, you can see that there are 4 electrons will be there in p orbital. Is it right? Hence, along with the 2s, is it right? It forms what? 6 unpaired electron in the excited state. Is it right, children? Yes. So during the excited state, the sulfur can form 6 electron as its unpaired electron instead of forming 2. Is it right? Yes. So, and these 6 electrons will be get occupied or get paired up with the 6 fluorine atom and forming what? SF6 structure. But always remember, if you write it in a ground state, you know, it consists of 3s2. There are 2 electron which is present in the ground state of s orbital, where it has a act like a lone pair of electron. So it is a 1 lone pair of electron which is present in the sulfur. Hence it forms a trigonal bipyramidal structure. We will discuss with the AB3E2 type, where the central metal atom has 2 lone pairs of electron with the 3 bond pairs. You can see that this is a central metal atom having the 2 lone pairs and with the 3 bond pairs, and usually it exhibits in a T shape. The best example is ClF6. Okay. In the chlorine atom, there are 17 electrons will be there. In that, there are 2 pairs of lone pair of electrons will be there, and remaining 3, you know, it will be combined with the fluorine and forms a ClF3 structure. Next, we have last 2 type, that is AB5E. In that, central metal atom has only 1 lone pair of electron and with a 5 bonding pairs of electron. Example is BrF5, that is bromine F5, and it has a shape of square pyramidal, or you can say that it is a octahedral shape. Why it is known as square pyramidal? Because the 4 central atoms, it forms a square shape. Hence, it is known as square pyramid or octahedral structure. Next is AB4E2. In that, central metal atom has a 2 lone pairs of electron and it has a 4 bonding pairs of electron, and this is a general representations of central atom with the 4 bond pairs with the 2 lone pairs of electron. Example, ZeF4, that is xenon fluoride or hexafluoroxenon, okay, and it has a square planar structure because it consists of 4 hybrid orbitals which is occurred in a square plane, okay. So this is how we can easily predict the structure of molecule either by considering the molecule with the no lone pairs of electron, either by considering molecules with the lone pairs of electron. So hope you all understood with this concept. Now let us see how to predict the structure of molecule based upon valence shell electron pair theory. So first I'll go with the beryllium chloride. This is the best example where the central metal atom has no lone pairs of electron. Is it right? Yes. So in a beryllium chloride molecule has a Lewis dot structure as I have written here. The central beryllium atom has 2 bond pairs in its outermost shell, and the repulsions with these 2 pairs causes the molecules to be linear. Is it right? It consists of how many electrons? 2 electrons in the outermost shell, and this you can write it like this also. So this is a cation which consists of 2 electrons, and these 2 electrons are get occupied or get paired up with the 2 chlorine atoms and results in the formation of what? Beryllium chloride. Beryllium chloride structure with a bond angle of 180 degree. With the bond angle of 180, you can see that the central metal atom has no lone pairs of electron. Next, the boron trifluoride, that is BF3. So in boron, in BF3 molecule, boron atom has atomic number of 5 and its valence electronic configurations will be 2, 3. Thus, boron has 3 valence electron and these electrons are shared mutually with the 3 fluorine atom to form BF bonds. In BF3, the boron has no lone pair of electron, hence it has a regular geometry. Already we have understood that boron which consists of 5 electrons, in that it consists of, so it consists of 3 electrons as an unpaired electron, and these 3 electrons will be get paired up with the 3 different fluorine atoms and forms a regular trigonal shape or regular trigonal planar structure. Remember, in case of this BF3, there is no lone pairs of electron and there are 3 bond pairs of electron will be there, and number of electrons will be calculated as by counting lone pairs by bond pairs. So it is 3 plus 0, it is 3. Okay. This is how, by understanding if the molecule has a lone pairs of electrons or not, we can easily predict their shape. Next, I'll go with the methane. Again, in the methane, we know that the carbon is now having no lone pairs of electron and it has a 4 electrons in its outermost shell. All the 4, electrons are get paired up with the 4 different hydrogen atom and forms a regular tetrahedral shape. Okay. So, in case of carbon, we know that it has how many electrons? 6 electrons. Is it right? So, 2s2 and 2p2. So, these are the 4 electrons which is present in its outermost shell. All these 4 electrons are get paired up with the 4 different hydrogen atoms and forming what? Tetrahedral geometry. You can see that these are the 4 bond which has been exist between the carbon and hydrogen. You can see here it consists of 4 bond pairs with the 0 lone pairs, and you can see that the total number of electrons can be obtained by adding 4 plus the lone pairs as well as the bond pair. So the total number of electrons will be 4 because in the carbon there will be a no lone pairs of electron. Now let us see with the shapes of the molecule. We know that when we are writing the shape of the molecule, oxygen is a central metal atom. We know that the oxygen which carries how many lone pairs of electron? 2 lone pairs of electron. In water molecule, oxygen has 2 lone pairs of electron and 2 bond pairs of electron. The shape would be tetrahedral if where all the bond pairs but the 2 lone pairs are represented, so the shape will be distorted to the tetrahedral or with the rectangular or with the angular shape. The reason is the lone pair repulsion is more than that of the lone pair bond pair repulsion, which is more than the bond pair repulsion. So the angle is reduces from 104.5 from 109.5 degree in the water molecule. Hence it has a bent structure. So why it will be get distorted? Due to the more repulsion between what? Lone pair repulsions. You can see that in case of oxygen, how many lone pairs will be there? 2 lone pairs of electron will be there and 2 bond pairs of electron will be there, and it has been shared with 2 different hydrogen atoms. This is how we can easily predict the shape of water molecule even though it consists of 2 lone pairs of electron. Now let us take one more example, that is in ammonia molecule. In ammonia molecule, nitrogen has how many lone pairs of electron? Only 1 lone pairs of electron and 3 bond pairs of electron. Okay. So in ammonia molecule, nitrogen atom has 1 lone pairs of electron and 3 bond pairs of electron, and there is been bond pair in place of lone pair, and shape will be tetrahedral, but 1 lone pairs will be present in ammonia. Hence the repulsions will be caused due to the lone pairs and bond pairs, so that the bond angles which has been get reduced from 109.5 degree to the 107. So hence it has a pyramidal shape. You can see that it has what? Pyramidal shape, which is having 1 lone pairs of electron and 3 bond pairs of electron. This is how we can easily predict the molecule's shape based on the molecule, even though it consists of lone pairs of electron or even though it doesn't consist of a lone pair of electron, we can easily predict it by using what? Valence shell electron pair theory. So in the next class, we are going to discuss more about the molecular orbital theory, that is MOT. So by this I like to say that which are all the concepts which I covered in the session, especially with the valence electron shell pair theory, try to focus on it and try to work out with the structure of the molecule, how we can predict it based upon valence shell electron pair theory, and the postulate will also be asked for 3 marks. So hope you understood with this session. We'll meet you with the next session. Till that, take care, be safe. Thank you.